Don't be surprised if I tell you that 85% of the universe is completely invisible. Take a look at a galaxy. It's a glittering city of 100 billion stars, and it seems so solid, so permanent, but that's just a cosmic illusion, because everything we can actually see, every star, every planet, you, me, all of it makes up only 15% of what's truly out there. The other 85% of the universe is completely invisible. It's a hidden, cosmic web of something mysterious called dark matter, and it's the only thing holding our universe together. Without it, the very stars you see in the night sky would have been flung out into the void billions of years ago. So the real question isn't what's out there, but asterisk, what is it? To wrap your head around this, we need to go back to the 1970s and meet an astronomer named Vera Rubin. She was studying how galaxies spin. Now, you'd expect that stars on the outer edges of a galaxy would move slower than stars near the center, right? Just like Neptune orbits the Sun way slower than Mercury. Think of it like a mirror. The kids on the very edge are always the most likely to fly off, but that's not what she found. The stars on the edge were moving just as fast as the ones tucked in close to the middle. They were going so fast, in fact, that the gravity from all the visible matter in the galaxy was on nearly enough to keep them in orbit. The galaxy should have torn itself apart. The only way this made any sense was if there was a huge, invisible halo of mass wrapped around the entire galaxy, giving it the extra gravitational grip it needed to hold itself together. This was the first major clue that something else was out there. The second clue comes from something called gravitational lensing. Einstein figured out that massive objects literally warp the fabric of space and time. So, when light from a distant object travels through that warped space, it bends. Astronomers can use this to basically weigh galaxy clusters. The problem, when we look at the light from distant galaxies, it's being bent and distorted way more than all the visible matter can explain. It's like there's an invisible lens there, and its gravity is leaving fingerprints all over the crime scene. The final piece of the puzzle comes from the very beginning of the universe, the faint afterglow of the Big Bang, called the cosmic microwave background. When we map it out, we see tiny temperature fluctuations. For those little hotspots to grow into the enormous galaxy clusters we see today, they needed a kind of gravitational scaffold to build on. Normal matter, on its own, couldn't clump together fast enough, but dark matter doesn't interact with light, so it could start clumping together much earlier, forming the invisible framework that all the visible matter eventually settled into. So, the evidence is pretty overwhelming. We see dark matter's gravitational pull everywhere we look, but that just tells us what it does, not what it is. And for decades, the hunt has been on for the actual particle, or, for a long time, the main suspect was a particle called a WIMP, which stands for Weakly Interacting Massive Particle. The idea was these were heavy, slow-moving particles that almost never interact with normal matter. To find them, scientists built these incredibly sensitive detectors deep underground, shielded from cosmic rays, basically just sitting in the dark, waiting for a dark matter particle to finally bump into one of their atoms. But so far, nothing. Every experiment has come up empty. That silence has pushed scientists to look at other, more exotic suspects. The leading contender right now is something called the axion, a hypothetical particle that's extremely lightweight and acts more like a wave than a particle. Experiments are using powerful magnetic fields to try and coax these axion waves into converting into tiny particles of light that we can detect. So far, no luck, but with every experiment, they're narrowing down the places this ghost particle could be hiding. The identity of dark matter is still one of the biggest unsolved mysteries in science. It's like we have a perfect police sketch of the culprit. We know its mass, how it's spread across the universe, and that it's allergic to light, but we have absolutely no idea who it is. But the hunt is far from over. A new generation of tools is coming online, including the Vera Rubin Observatory, beginning its work in 2025. The Rubin Observatory will spend 10 years creating the most detailed map of the universe ever made, charting dark matter's influence with unbelievable precision. It won't find the particle itself, but it will give the particle physicists a much better idea of where to look. We live in a universe that is shaped and controlled by an invisible substance, a cosmic web that dictates the fate of every single star and galaxy, and we are just now, finally, beginning to pull at its threads.